Hello student, this video is on concept of ADC used in Arduino Atmega 328P with the different analog functions. Through this video we will learn the different analog functions. First we will see about the ADC. ADC, we know that it is the analog to digital converter. Arduino Atmega 328P has a circuit inside which is called as ADC, or in short, or it is even the analog to digital converter. Now we know that we uses the different analog sensors to measure some physical quantities such as pressure, temperature, or the humidity. So in order to read the analog sensors, we need different types of pins. Arduino Atmega 328P has 6 analog pins from A0 to A5. These are the analog input pins on Arduino Uno board. A0, A1, A2, A3, A4, A5. These pins tells us the voltage applied to them as well as its the value also. Now these are the different features of ADC in Atmega 328P. ADC is the 10-bit, it has the 10-bit resolution from 0 to 1023. It has the absolute accuracy about the plus minus 2 LSB with the conversion time 13 to 260 microsecond. It has the 6 multiplexed single-ended input channels with the 2 additional input channels also. It has the temperature sensor input channels as well as it has the optional left adjustment for ADC result readout. It also has the sleep mode noise canceller. So these are the different features. Now we see the different analog functions. We know that Arduino Atmega 328P has some 3 analog inbuilt functions. These are analog read, analog write, analog reference. First we will see about the analog read function. Analog read function is the analog input function. It reads the value from a specified analog pins, that means from the A0 to A5. It is used to read analog input voltage between 0 to 5 volt, and it will be then converted into decimal values from the range 0 to 1023. Why this the 1023? Because we know that ADC in Arduino is the 10-bit resolution. That means 2 raised to 10. 2 raised to 10, we know that its the value is the 1024. So if we count it from the 0, it will be 0 to 1023. Now suppose analog read voltage is 0, then it will be converted into 0 decimal, or if read analog voltage is 5 volt, then it will be 1023, or if it is the 2.5 volt, then it will be converted into decimal 512. This is the analog syntax, analog read function syntax. Its syntax is analog read in bracket pin. Pin is the analog input pin from which we read the analog input voltage. We can write pin from A0 to A5. Suppose student, we write analog read in bracket A0. Then this the function reads analog input voltage from A0 pin. Now the second analog function is analog reference function. Similar to analog read function, the analog reference function is also analog input function. It configures the reference voltage used for analog input. The function is used to select reference voltage type. Syntax for the function is analog reference in bracket type. Which type of reference to use. We can use the type such as default or internal or external. If we use the type such as external, then the voltage applied to the AREF analog reference pin is used as a reference. Student, for example, if we write analog reference in bracket default, then the function is going to select default voltage of Arduino board. It may be from 0 to 5 volt or it may be 0 to 3.3 volt. It depends on which type of Arduino board we used. Now the analog write function. Analog write function is the digital output function. The analog write function is used to generate PWM wave. That means it writes an analog value, PWM value, to a pin. The pin may be the D3, D5, D6, D9, D10 and D11. In the last unit, we learned some digital input output pins. In that, we learned that these Arduino Atmega 328P has the 6 PWM pins. These are nothing but these. Pin number 3, 5, 6, 9, 10 and 11 are the PWM pins. If we carefully observe on this the D0 to D13, then we get the difference is that on this the analog on this the PWM pins there is a symbol, intil symbol is there. It indicates that these are the PWM pins. After a call to analog write, the assigned pin, that means from the 3, 5, 6, 9, 10, 11 pins, any pin will be generate a steady rectangular wave of a specified duty cycle. The analog write function is used to vary the brightness of LED light or to vary the speed of the motor. The syntax for analog write function is analog write in bracket pin comma value. Pin, that means it may be 3, 5, 6, 9, 10, 11 PWM pins, and the value is the duty cycle value. We can write the value between 0 to 255. This is the range for the duty cycle. If we write the 0, that means it is always off. If we write 255, that means it is always on. Student, if we write for example, analog write 5, 255, that means this function generates the PWM waveform of 100% duty cycle at pin number 5. Similarly, if we write analog write 3, 128, then that time the analog write function generate the 50% duty cycle at pin number 3. Like this, we can select the duty cycle between the 0 to 255. Now there is one concept, that is the ADC prescaler. Now we know that ADC, that means it converts analog signal into digital signal, and this with at some regular interval. This the interval is determined by the clock frequency. Now ADC operates with the different frequency range, that means from 50 kilohertz to 200 kilohertz, but the CPU clock frequency of ATmega 328P is much higher. It is in megahertz. So that to achieve it, frequency division must be take place. This the frequency division, or this the division factor is done with the help of prescaler. It produces the desired frequency from a external higher frequency. There are some predefined division factors such as 2, 4, 8, 16, 32, 64 and 128. So student, this video is about the ADC concept. Through the video we get the idea about the which different analog functions we used and what is the syntax. Thank you students. If you have any doubt, you can ask me.